Hello and welcome to the Wow Info YouTube channel. We are your go-to source for fascinating insights into the everyday phenomena we often overlook. Today, we're tackling a question that's puzzled many a breakfast table. Why is milk white? This seemingly simple inquiry opens up a world of scientific discovery, from the composition of milk to the way light interacts with its particles. So sit back, grab a glass of your preferred milk, and get ready as we unravel the mysteries behind this ubiquitous beverage. Why is milk white? What's the role of fat and protein in its color? How does light scattering come into play? We'll answer all these and more in this video. Stay tuned because you're about to look at your morning cereal in a whole new light. Have you ever wondered why milk is white? It's a question that might have crossed your mind while pouring a glass of the frothy liquid or swirling it in your morning coffee. The whiteness of milk is something we take for granted, but have you ever thought about why it's that color? Why isn't it clear like water or yellow like oil? The answer lies in the mysterious world of science and the fascinating composition of milk. It's not a simple substance, but a complex mixture of water, fat, proteins, and other compounds. These constituents interact in intriguing ways, bestowing upon milk its characteristic whiteness. But it's not just about the components. There's more to the story. How does light interact with these particles to give us this color? What role do fat and protein play in this process? Well, it's not magic, it's all about science. Let's dive into the world of milk and uncover its secrets. To understand the color of milk, we first need to understand what milk is made of. At its most basic, milk is a cocktail of water, proteins, fats, lactose, and minerals. But don't let this simple description fool you. This seemingly straightforward concoction is a marvel of nature's chemistry. First up is water, the most abundant component of milk, making up about 87% of it. Water serves as the medium that allows the other components to interact, mix, and create the texture and consistency we associate with milk. Next, we have proteins. Milk contains around 3.5% of proteins, the most significant being casein and whey. These proteins are responsible for the nutritional value of milk, providing essential amino acids necessary for growth and development. Then, we have fats, which contribute to about 3 to 4% of milk. They are primarily in the form of triglycerides, which give milk its creamy texture and rich flavor. These fats also carry fat-soluble vitamins like A, D, E, and K, making milk a nutrient powerhouse. Lactose or milk sugar is another key component, making up about 4.5% of milk. This carbohydrate not only imparts a slightly sweet taste to milk, but also serves as a vital energy source. Lastly, we have minerals or salts, which contribute to less than 1% of milk. These include calcium, potassium, and magnesium, among others. These minerals are essential for various bodily functions, including bone health. When these components come together, they don't just mix like sugar in water. They form a unique structure called a colloid. In this colloid, tiny fat globules and protein molecules are dispersed throughout the water, creating a stable, homogeneous liquid. So milk isn't just a simple liquid, it's a complex mixture of different components. Each ingredient plays a crucial role in giving milk its characteristic color, texture, and taste. And it's the interaction of these components that will lead us to the answer to our original question. Why is milk white? Did you know that the fat and protein in milk play a crucial role in determining its color? It might seem strange, but it's true. Let's dive into the fascinating world of milk to understand how this happens. Milk is a complex concoction of water, fat, and protein, among other things. But it's the fat and protein that we're focusing on here. These two components are dispersed throughout the milk in the form of tiny particles. The fat in milk is present as small globules. These globules are not uniformly distributed, but rather they are scattered throughout the milk. The size and distribution of these fat globules are one of the key factors that influence the color of milk. Larger globules tend to scatter more light, resulting in a creamier, whiter appearance. Now, let's talk about the protein. Milk is rich in proteins, particularly casein and whey. Just like the fat globules, these protein molecules are also dispersed throughout the milk. But proteins, unlike fats, have the ability to dissolve in water. This unique property allows them to form a colloidal solution with water, a solution where tiny particles are dispersed but not dissolved. The proteins in milk, especially casein, have a knack for scattering light. When light hits these protein molecules, it gets scattered in every direction. This scattering of light by the protein molecules is what gives milk its characteristic white color. But here's the catch. It's not just the individual roles of fat and protein that matter. It's also about how they interact with each other. The fat and protein in milk work together to scatter light in a way that gives milk its creamy white color. So, next time you pour yourself a glass of milk, remember, it's not just a simple white liquid. It's a remarkable blend of fat and protein working together to create that familiar color we all know and love. So, the fat and protein in milk are the main contributors to its white color. Fascinating, isn't it? Now that we know about the role of fat and protein, let's talk about light. Light, as we know, is a form of energy that enables us to see the world around us. But it's not as straightforward as it seems. Light is composed of different colors, each with its own unique wavelength. These colors blend together to form the white light we commonly see. Now here's where it gets interesting. When light interacts with an object, several things can happen. It can be absorbed, reflected, or scattered. Absorption is when light energy is taken in by the object, often heating it up. Reflection, as the name suggests, is when light bounces off a surface. But let's focus on scattering, the phenomenon that's crucial to our discussion. Scattering is when light hits an object and gets sent off in different directions. The degree and pattern of scattering depend on the size and nature of the particles the light encounters. So, how does this relate to milk? Well, milk is a colloidal mixture, meaning it has tiny particles of fat and protein suspended in it. These particles are just the right size to scatter light, especially the shorter blue and green wavelengths. When light hits these particles, it gets scattered in all directions, and this scattered light is what our eyes perceive. But why does this scattered light appear white? Remember, light is composed of various colors. When all these colors get scattered equally, they combine to form white light. That's exactly what happens in milk. The fat and protein particles scatter all the light colors equally, resulting in the milky white color we all know and love. So there you have it. The color of milk isn't about the color of the particles it contains, but rather how these particles interact with light. So it's the scattering of light by the fat and protein that makes milk appear white. So why is milk white? Let's encapsulate the essence of our discussion. We've discovered that milk is a fascinating cocktail of water, fat, proteins, and carbohydrates. Each of these components plays a vital role in giving milk its characteristic white color. The fat and proteins in particular are the main actors on this stage. They are tiny particles that are dispersed throughout the liquid. When light hits these particles, it doesn't just pass through. Instead, it gets scattered in all directions, a phenomenon we've referred to as light scattering. This scattering effect is what makes milk appear white to our eyes. It's a complex dance of physics and biology occurring in your everyday glass of milk. The color of milk isn't just a visual quirk, but a testament to nature's intricate design. So the next time you pour a glass of milk, remember the fascinating science behind its color. That's all for today's episode on the mystery of milk's whiteness. If you enjoyed this video, don't forget to give it a thumbs up. Share it with your friends and family who might also find this fascinating. The color of milk isn't just a visual quirk, but a testament to nature's intricate design, and we'd love to hear your thoughts on it. So, go ahead and leave a comment below. Do you have any more questions about the science behind everyday phenomena? Let us know. We're always excited to delve deeper into the mysteries of the world around us. And most importantly, don't forget to subscribe to the Wow Info YouTube channel. We've got plenty more intriguing insights to share with you. Thanks for watching. And remember, never stop asking questions, never stop learning, and always stay curious.